Hello, everyone. Today, I am remembering... Wait a minute. Hold on. Oh, you guys probably... hold on. Wait. No, I messed up. The deck talk was probably working.
Deck
I just
talk
can't
is
hear
now
it.
Online. End of line.
There we go. Now I can. It was my fault this time. You know, unlike every other time. One moment. Just getting things ready here that I forgot because I set them up on the other computer and didn't think about doing it over here. And there was a thing I forgot to plug in. I was like, oh yeah, I can just plug that in later. It'll be fine. And then I didn't plug it in later, and now it's not fine. Now it's probably going to be a pain in the butt. Oh, that's awful. We kind of need this. There we go.
Testing 1, 2, 3. It's actually all Ben's fault at the end of line.
Chloe, thank you for the 100 bits. And, oh, it just worked. Okay, we'll take it. It looks terrible, but I'd rather it just actually function. So, oh, it even popped up for some reason. Weird. Oh, I don't have a key for that. That's right. Okay, we're just gonna... Oh, you know what? Let's get crazy. Do 720 by... I don't have DVD resolutions.
2025 SICHER 100. Thank you for everything, Shelby. Because of you, I am now archiving a ton of 5¼ discs now on the Windows 98 system. End of line.
Crazy boy, that's awesome. And thank you for the 100 bits. Okay, let's go over what all we're doing today. We're doing basically what we should have done yesterday. We're going to be working on the serial interface software that controls the Data General Micronova from a modern computer. There are a couple of twists on how we're doing it today, though, because I finally implemented something that's going to be really nice. We're not going to end up using the dasher at all today, most likely, unless we like totally knock this out of the park and I get bored and I want to make a cable that adapts this to DE9, but you'll see why later. But for now, let me show you something. So this is the computer, duh. And over here is a modern computer. I'm going to take the old one, crank it over to reset, and then to run. And there we go. We have the address being displayed of where it was last executing or whatever that is. I'm not 100% sure. However, we can make this more interesting. Because if I go over to there, and then I do this, and I do this, I can regret the positioning of the scanner there. No, I'll just push it out. You'll see we have the delightful little Weiss terminal set up here. And what I can do is I can go over to the modern computer here. I'm going to run a D6 space 2 and then confirm, and then a C6 space 7. Boom. And now we have the data general right here. So that's pretty handy. What I have going on is over here I have controls for this thing. This is an 8-port serial switcher that I can control over software. And utilizing that, I can redirect the console from the Micronova to either another USB serial interface that I have on this computer or the actual terminal. Eventually, the goal here is to be able to have this thing just in the rack for the Micronova. Probably, maybe, we'll see how it goes. And then the dasher will be connected to it. The computer for the Micronova will be connected to it. But then when I want to, say, transfer data to or from it, all I have to do is just connect another serial cable into this thing. And then I don't even have to rewire any of the other stuff, because the cables for connecting to the serial ports on the Micronova kind of suck, and I never want to have to use these. So that is what I need to do. The C command doesn't disconnect other connections. No, it just won't do anything with them. So if I try to connect the Micronova to the USB port, it says busy. So yeah, it won't disconnect them, but it also won't dual connect them. Yeah, so initially I wanted to be able to connect both the USB interface and the physical terminal. Turns out that's not possible. At the same time, that is. I tried doing some stupid stuff with some splitters earlier. It doesn't work. So I don't really have a way of using the computer from the physical terminal while also sending it data or reading data from the computer, the modern computer, that is. So, very frustrating. So much simpler with a proper terminal server, like a whatever thing. I don't care. I'm not spending $200 on a serial thing. This was 35 bucks. My value per functionality, a lot higher on this. Okay, spin up a telnet server? When someone ports telnet to the Micronova, sure. It's there's no way to do that. Telnet and develops an Ethernet card. Can I increase the font size? Yes. So this, don't worry. This is not like necessarily fully what we're looking at today. Matter of fact, I can close this in some way. Control A, X, leave minicom, and there we go. Okay. So our actual objective for today is this here. So only one console port on the Nova. For the debug console, yes. There are 2 async cards. I believe the second one could be utilized at the same time as the first. Man, I can't see any reason why you wouldn't be able to. But only one of them can be the debug console. All right. So what this code is this stuff. So this is my in-progress software. BCF84, thank you so much for the tier 1 sub there and for 34 months. I appreciate that.
1111000111110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110001110
Crazy boy, thank you for the 100 bits. That was a loud thump. Finding out about the Bendix G15. Yeah, I haven't had a chance to watch that today. Our goal here is to take the Micronova console and then control it with a Python program for reading and writing to larger chunks of memory at once. Yesterday, we were able to kind of dump the console debug ROM, which is exposed through the address of RAM range thing. It wasn't perfect. I kind of wanted to take another crack at that. And then we're outputting it as JSON here. That is not how I want to actually input or output data, because could you imagine having to format a program into JSON blocks? That sounds awful. So we need this to work on binary data. So we're going to have to bring in the file binary read write. So, but yes, let's rerun this just so that you all have an idea of what we're doing. So I'm going to set the serial port to be TTY USB 1 this time, because the other one is the console that I'm using to manage the, the serial switcher. That's it. Okay, so I'm currently on the real terminal, which I'm gonna go ahead and shut off because I can't really film it for you guys. I was using it earlier. So we're gonna disconnect 6 and 7, I'm sure, and then I'm gonna connect 6 and 3. There we go. No, not bus 1. Hold on. Disconnect 6, 3. Yes. Connect 6 to 2. There we go. USB console. Fun fact here. If I do this, it'll print out all the port names. So I named all of these. I did not name that one. That's how it came. Anyway. So we can go here now. I'm going to go ahead and just delete these so that we can see what the error was. We're going to run dg. Why is this not executable? Chmod plus x dgcon. Okay. Why did it make my cursor funky? JSON. User end Python 3. What on earth? I can't change the font size of the text browser. This. One moment. This gets to be a pain in the butt doing this stuff on one monitor in a small area. Okay. Why? What? File serial PostScript document text. What? How did I take a screenshot by running a Python script? Okay. Right. What? I forgot the shebang? No, it's there. That's correct. User bin env python 3.
Chlorocoon says CHEER 100 NU redeem. Ban Python screenshot. End of line.
Thank you for the 100 bits. That was the wrong serial port there, so this will... String literal. Oh my gosh, how did I end up with funky quotes? That shouldn't be possible. What? There's a space. Oh. There is. Okay, that'll do it. Well, now we can do DG con. There we go. Okay. Now, for some reason, the first one returned something bad. 400. I think there may have just been more buffer data. So we need to run a clear first. So we'll do that. We'll clear and then we'll flush the buffer. So one of the things that I didn't do yesterday that I don't like, and we're gonna fix today, is rather than just do a replace like this where we just remove what should be there, for our results, we're going to go ahead and do a regular expression, and we're gonna make sure that the input is correctly formatted. So let's look up how to do that, because I don't know how to do a Python regular expression string match. Python regex string match true false. RE search. What is input? Okay. So we import RE and then we do something to that effect. Okay. Import RE. And then let's do... So I have these samples here, but we can go ahead and do this a little differently. Self dot response read address equals, and just for giggles here, we'll put this here. If print, yep, okay. Regex anything in Perl looks like makes me miss Perl. Yeah. All right. So response address. Okay. So this is going to be funky regex. So we have a 0 through 7. Can I regex car repeat? What do I want it to do? So there are, what, 6 characters here? I could just do that. That feels a little bad. Okay, just brace 6. Okay, that I like. Brace 6. Okay. Okay. Then the result is this, and then a space, and then basically the same thing again. Now, I'm not going to count our input. Although that is the input. Hold on. Let's just really quick. 1, boom. Okay. So we type in our address. So it would be address. Okay, let's try this differently then. Let's move this here. That would be the address, and then this is our value. Okay. Yeah. So we could do result will be, we should use command read. Will automatically zfill. Okay. So address plus this self dot. Think that'll work. Okay. I am going to do dg address read 77400 and then just exit. Oh, it's sys.exit or something stupid. Yeah, I want to just that's not what I wanted. There we go. Problem solved. Okay. Back to here. Not install gimp dg con. dg command read. What do you mean no command read? Self command. Oh. Duh. It did not pass? What? Is this more octal nonsense? Address. Okay, I'm going to print out the test string. This is confusing. Nope. Is it not evaluating it? All right, that's fair, Ben. Fine. I don't know what I'm writing here. That seems weird. What's the purpose of this exercise? To be able to directly access large portions of RAM at once. We kind of did this yesterday. Let me just give a quick demo. So this is the console for the Data General Micronova right here. It is running right there. I am connected to it. I just read memory address 1 and got this back as a result. I can then hit Control J, get the result for address 2, address 3, 4, and so on. Now, that's just kind of random blank memory. There's nothing exciting there. But if we do 77400 and read this, we can go through and see that there is data there. This is the ROM, that is the actual code that is this console interface that I'm using. As far as I'm aware, this hasn't been backed up as binary data. Apparently it's in a printout in a document somewhere on Novazor forever. So what I want to do is I want to dump this. Now we kind of did this yesterday, it just sucked because we did it as a bunch of dictionary values in JSON, and that's awful. So I'd like to just make sure that we can do this correctly. So I want to be able to export this to binary data, which would be good because then we could also upload binary data. So if we have a raw block of code, we could then just straight up write it into memory over serial, and then we could run it. Because in this, all you have to do to be able to run something is type a number, not that, type a number for the address, and then type R. If I typed R right now, the machine would halt and crash, and I'd have to go over and restart it. So I'm not going to do that, but that's how that works. So you just type in an address and R. So if we could just load software into memory, set the address, or type in the address at the initial point where we started loading it, type R, and then run any machine code that we put into it. So that's why this gives us the ability to directly load machine code into RAM, which is going to be important. So this, what we're currently doing is trying to come up with a way of validating responses to make sure that we're correct, that we're in the, like, a known good state. So for example here, on init, I should have this do a read, or I should say I should have it do a self.write with the command cancel, which will always put us back to the question mark thing. And then I'm going to do a self.read just to clear the buffer. So we'll call this init serial interface. That way we always know what state we're in. If I type R right now, it will crash when I have a DG question to Microsoft. It's just because it's such a low-level interface. That's why. You're telling it, run the instruction at this address, and that address is an invalid instruction. It will attempt to run it, but it won't work. Thanks for explaining the situation. No problem. Okay. Let's try the bigger thing again here. This should technically, I didn't octal the address, that's why it was wonky. Okay. Yeah, I believe that will work. All right. Save and run. That's not what I wanted to run. Okay, that was a fail. Right, some weird value. I don't know where that's coming from. K. And then whatever that is. Why? Why is it writing that? Where is that coming from? I need Python accept. No. I need raising. There we go. Raise. Okay. Raise. Okay, Python raise. That's the same level as those Z80 CPU trainers? Yes. All right, I just want a, like, good raise exception. That's perfect. Okay. Okay. We won't print yep. We'll just do if not, and then that. Okay, number. F. Result. Result. That was almost the correct way to type result. Did not match. There we go. All right, let's rerun that. Make sure that it properly crashes. Perfect. Okay. Now we need to figure out why we're sending that. Do you get proper handshake? So the handshake, we don't need handshake. Turns out the console just doesn't care. It's just straight up RX and TX. That's it. That number is decimal 77400. So there's a conversion shenanigans. Well, that's weird. Why is it being written twice? Did all the other ones only once before, and then it does this one twice. First one is octal, or not, or is decimal. Stupid computers. Line 60. Oh, it is. Why? Good catch there. How about we just don't do that? Okay. That looks good. Why was I doing that? All right, do they expect a human to use a console? It doesn't, yeah, they can't go as fast as another computer, yeah. Okay, exception, result, thing did not match. Yeah, that's correct. Okay, because we need to end this one before. So this will be 5, 5, 7. All right. Now this should work. Prime pump start address. I think I was thinking that, but that clearly was the wrong answer. Not match. 5, 5, 7. Well, that's weird. Did we write it and then not actually read the data? Okay, self response if address equal end. Command break. We need to get rid of this next, that's for sure. And today we are working on our program for manhandling the memory of the Micronova over the serial console interface. Okay, that worked. No, I think I left a stray command. That was perfect. No errors. Bam! Okay, so we can check this now. Responses all correctly matched. What was expected? Why do you also do if address and... Because I wrote most of the logic of this code before I actually even got it working with a serial interface. This was just like a stub thing up here, so the logic was not fully sorted. So let's just run this one more time, validate. All right, Ben, you've been poking around the files. I got a question for you. All right, you've been looking at the binary data. How would I best pack these values? Because we effectively have half of the data here that we could. Yeah, see, that's the problem. I'm thinking I had an MSB LSB switch for just doing the byte swapping, like, as part of the process. Now to parse this into bin hex. Yeah, we're gonna do that, but it's complicated. What do I mean half? So our values are only 0 to 7, whereas most data is 0 to 6, or 16. It is also how you interpret it. Should I have all of it now? What am I missing? I don't want a JSON file. It needs to be binary, because JSON is useless. Like, this sucks. I don't want this. You want to parse this to have it be, to try and run it through your disassembler? That would be garbage. So we need to write this to binary. This was just to validate that the queries in the response. So Octal just convert it to hex or whatever. That's a bad idea. At least I'm pretty sure. So if we do, let's look at this. Here, archiving, bulk image, and we look at HP swap in imhex. Vorpal store, that's literally what I'm saying I'm gonna do. So this is the machine code here, and I'm seeing lots of values that are over 7. That's what I'm saying. Because the way that it's going to be parsed is going to be weird. Yeah, sir, for everyone not really getting what I'm talking about, okay? The way that the bits are interpreted between the machine code monitor and, say, this are different. Yeah, that is... So we would do, can you display it as octal? I mean, I am displaying it as octal. It's just, okay, so let me think about this. So if we go through the responses, we would condense them to hex. Okay, if we do hex... Or are they octal already? They're not. So let's do this. Return oct. So let's try this. Let's just run it this way. I want to see what it puts in the files. I'm not familiar with how this works with Python when you're like encoding or decoding stuff. It's kind of weird. No, I don't. I know how to write binary data. We did that with the Hydro Thunder time tool. You just open RB into the file. So what'll basically happen is I'm just going to reiterate over the response array and then just write them out sequentially. One of the reasons I want to do that, at least for the console ROM, is that when we get to the invalid address spaces, I'm going to have some phony data that's all ones that I put in there. So at least for the console ROM, we're going to kind of fudge this a little bit. For everything else, we'll just let it be normal. What was I looking at? I was going to... I completely lost my train of thought. Oh, it's going to go to here and delete the JSON files. To add my... Yeah, okay. Alright, so we run this again. And error. Dict object cannot be interpreted as integer. Okay, so I'm apparently doing that. Oh, I did that the wrong place. Here. Not string. Oct. Okay, now run it. String cannot be interpreted as an integer. Int. Oct. Okay, well that's wrong. Huh. It's not two ROM chips. In the middle of the console ROM, there is a space that is, for some stupid reason, used to shadow memory for the CPU address register, or CPU registers. Okay, so the result is octal, but it's a string. It's not just string, is it? That would be stupid. I don't think it's going to work. Oh, that's... Okay, so... int and then base. Well, this is going to be... I don't know what it's going to complain about here. Probably going to tell me it needs to be an int. No, that's still not right. Is that because I'm re-parsing it? Get rid of that. That's not right. Or is it? Okay, hold on. Let's try... We do a print result. It is right? Okay. All right, we'll go with that. Stay hydrated is what I was doing before. I'm now just trying to make it not stupid. You know, what we should do, actually, let's just do it this way. This print, we're going to move this up here. And we'll just do oct. And then we'll do this, I guess. No, okay. Because it's already octal as a string, that's it. Okay. The problem with hex printing is that it's never displayed as hex anywhere. The console itself operates in octal. It's probably an audio delay. That's a webcam. The audio doesn't go through that camera. Alright, reload. Okay. So now we do a hex of well, that automatically. Well, no. See. All right, here's my problem. These are 12-bit? They're 16-bit. Okay. This base conversion's really messing with me. I'm sorry. Oh, I get it. It's 'cause it sucks. The regular expression is wrong. This is incorrect. That's what it is. Ugh. All right, I want to run that one more time. Just it won't matter, but just for my own sanity to validate this. Yeah, okay. If you want to be pedantic, yeah. No, I want to be pedantic. Because my brain had not yet parsed that that first thing was 1 bit. Okay, now it makes sense. Now I get it. Okay. Now I'm there. I understand it. Okay, so now I will look at your struct pack, that thing. Do I have to import struct? I don't remember. No, okay. It is address and then value, but no, the value is not split. Okay. Struct, not... Jeez. Import a common data type. Required argument is not an integer. All right, now I'm going to do it my way. Trying to remember how the binary stuff works. It looks like we probably have to seek after every write, or else we actually have to manage our positioning ourselves. I don't remember what time underscore bytes is. No, I don't want a bookmark. Cancel. Byte array. Huh. Oh, actually, we can do this over here. We'll just go ahead and do both. Okay, so we're going to do both the write and the seek. Count. I'm not sure I fully understand that. We'll come back to that. I'm doing good, Matt. Hope you are too. Okay, so let's try for value in data. W right. Let's just try this first. See what happens. Then we'll just not have that. Let's just see what this gets us. Maybe I should just get rid of the second part for now. Okay. Bytes like object is required. Fun. Not a string. Wait, how is it still a string? Oh my gosh, that looks awful. I'll give it a try, just because. Um... 24. Probably a count. Well, we'll find out. I don't even see there is no. You know what? No, hold on. I'm just researching. Okay. I don't know how to do this. I would rather just learn. Rather than just guess throwing random commands at it. Because we're like 5 or 6 random commands into this. Okay. I think I get this. This will be selectable later. How is it not an integer? Oh, I suck. Wait, what? This is driving me crazy. Oh, I think it just worked because I forgot to get rid of the other thing. So, open with mhex. Yay! Soldering on the data general boards is a terrible idea. It's just bad at it. Okay. So if I pick this, mhex is like, why would you ever want octal decoding? Ew, gross. Let's see if that's even a thing. Mhex octal. Is this just too niche? Oh, it can be... Someone actually says octal. Format option, besides radix, it can be set hex. Okay. Where do I set format? View. The format option. Where do I set format? Oh, to only do addresses, not data? Lame. Alright, well... That doesn't seem right. So it should be 1024. But it's the Indianness wrong? Oh, I forgot to change. Oh, wow. Cool. Fancy. Imhex will actually reload the file instead of just crashing. There we go. That's better. Can't see the hex dump. There it is. Look. Well, there. No, I can't. Actually, I can make the UI bigger. I don't want to make the UI bigger because ImGUI is kind of wonky. Called a hex oct editor. Oct. Where's my port? Octal editor. This is looking better though. All right, so let's do this. Yoink. ROM top. And we'll rerun. Is OD actually here? Maybe. All right, hold on. Let's try this. Cat, ROM. Hold on. ROM. Bottom. Bin. OD. And be less. I don't like that. Okay, so it does need to be flipped. I guess. Yeah. Right? Let's double check this. $2,000, 44,560, 24,000. What's with the preceding 0? That's address. Oh, that's awful. Why? Why would it stick the address in there in such an indeterminable way? Ugh. But all right, that looks correct then. We can dump RAM to binary data. Okay. I'm not looking forward to going back the other direction now. Ugh. Okay, so we need to cheat to fix those. You know what? Here, I got an idea. I'm gonna double cheat. There we go. Ball's in your court, Ben. Add the padding for whatever between the two files. And join them into one ROM. Yeah, you can pawn it off on Majenko if you want. I don't care. I just don't want to do it right now. Okay, so we can now. I should actually get this pushed up to the Git repo. So let's fix this or commit this. Git status. Okay. Git commit -m can dump data to binary file. Boom, git push. Okay. Remember how many words are missing? Exactly why I didn't want to do it. Here, I'll do you a favor, Ben. One moment. Okay, 77555. Here we go. Get your screenshot, Ben. All right, we're good. We're good. All right. Why is there a hole in the middle like that? Because data general are insane. It's even worse because technically I think the last two values aren't even real. So if we go back to that, we do 77777, this one, if I remember correctly, this is a jump point for after power failure. So it would be, if you were running a program, this value would be replaced with the point in RAM where the instruction counter was. And then once power comes back, it would resume from there. So this isn't ROM, even though it's the last byte in the value of the ROM. And then I think this is also another thing kind of like that. I'm not 100% sure. But yeah. So for the record, this is the second byte of the debug ROM. I'm not sure why it's saying to go to that, but I don't know, whatever. Machine code conversion of the data disassembler. I think Ben has been working on that. All right, you guys want to try something weird? Something a little crazy? Want me to melt your brain a little bit, Ben? Because I know you were working on file system stuff. Phew! This... I am absolutely floored by this, okay? I don't even know how to begin with this. This is so crazy to me. These are the files from the mag tape
around here
for the Micronova DOS. Chloe, thank you for the 100 bits. So, here's CLI.sv. Here's sys. Oh no, sys is missing. But here's DK or DOS init. Here's edit. You want to know if there's an assembler? Boom, there it is. That's the assembler. There's micro boot. I don't know what that is. Probably important. There's sysgen. Does it fit on a single floppy? No. Okay, back. Here's where this gets crazier. I think you missed this. They were able to add some of these files to my boot disk and then re-encode it back to Flux, and here are CryoFlux raw stream files for possibly making a usable boot disk. Okay, what is going on here? Are we back? Back? Okay. What do you got going on? Okay, we're back. Okay. Let me, I'm going to be explaining this for the third time now. After they were able to decode the files from the mag tape image, they were able to add some of them to my boot disk and then re-encode the binary data back into Flux. And in theory, I can write this and we have a better boot disk. I don't know what's on it. So that's fun, but able to do more. No, we did not. One person did. So we're going to try this. I don't know what's going to happen. This is going to be complicated. But we'll see what works here. So give me one moment. They put Doom on it, yeah. All right, let me go grab a, let's see. I should turn on the floppy drive. All right, I'm gonna grab DS1 or AD, no, DS1 don't use. Nah, let's go with AD1. I don't remember it having anything like mechanically wrong. All right, so disk. Put this in the drive. Pop that down. It's not gonna contain Doom. Literally, it's a text-based computer. It's not gonna run Doom. Okay, so GW write boot test 00.0 raw to drive. I think this is B, right? We'll just go ahead and do a GW clean drive B here really quick. Yep, that's correct. Okay, GW reset.
CRAZYBOY 2025 SICHER 100 ASCII Doom incoming. End of line.
Thank you for the 100 bits, and I am acknowledging no other part of that. Okay. Let's find out. Flux underflow. What do you mean flux underflow? Okay, there we go. While that's going, I'm going to go turn the computer off. Because I need to start it with the floppy drive on. All right, back up and running. Okay. So there we are. We have the console, and we now have whatever this disk is. So I'm gonna go put this in. Let's see what happens. All right, 33L. All right, that's a fail. It's not guaranteed to be nothing. What we need to do is find the other boot disk. Where did I put that? There it is. Okay, here's what we're gonna do. I'm gonna pull the disk and throw it on the floor. Rawr. No. I'm just gonna set that there. Okay. I'm gonna reset the machine. All right. I'm gonna put nothing in yet. I'm gonna put in the good boot disk. All right. Go back over to the computer. We should be at 33L. All right. It should do file name. There we go. All right. Now I'm going to put in the other disk, and we'll see if the file system is valid and if we can access anything on it. So the boot sector apparently didn't survive the re-encoding process, but we don't know what else may be on there, so let's find out. Okay, so if I just hit enter, does not have sys on there, excuse me. Unfortunately, sys did not appear to be in here, so I don't know. But let's try CLI. Why can't I write? Because it has to be all caps. Command not. File not executable. Well, that sucks. Okay. I have encountered this when I tried to do something similar in the emulator. You do have to set some funky metadata. So we have to learn how to do that. And we're not going to be able to do that. DOS, it's probably all going to be the same. Yeah. So the files were added, but they don't have the metadata necessary to run them. We're close. We're close. We're not going to be able to get any kind of list or anything. No. So, yeah, unfortunately, that's going to be it. Stuck. So close, though. That's super duper close. Boot on the original copy of the right metadata set? Yeah. So I've actually done this as well. In SimH, you can just use the, there's a copy command. It's actually xfer to migrate a file from one disk to another, but it does not seem to copy the attributes. So I'm guessing that's how they did it. We need to figure out how to use xfer with the attributes. So I will get in touch with this person again about how to do this. Boot SV is useless, so we have the same one on the other disk. Actually, I'll be curious if they tried to put it on here. Not executable. Okay. Edit the metadata in imhex. We cannot. We have no way of redoing this. So, all right, that's the one test. Oh, zero. Okay, that's you. Okay. I didn't realize that. The permissions didn't move along with xfer. Okay. All right. Yeah, so so like I was saying, I tried to do that with a 6030, and the whatever the RDOS boot disk is to try and copy those files over. It did the exact same thing to me, where if we list it in SIMH from RDOS, you'll see that there's the metadata things that are missing. I think I did get SIMH installed on here, right? We can use that. SIMH, yeah. So let me just, real quick like here. And then home, transferring from magtape, carried over the data, edit that in the floppy now, okay. But that is way closer than anything else has gotten. One moment here. I already have a KIO? Oh, cool. Git pull. All right, and then local share console, and then I'm gonna go over here. The high-pitched whine in that floppy drive is brutal. Oh my gosh. Just one moment here. Okay, then I think I put the RDOS file here. Yeah, let's not do that. Home. Create new text file. Okay, we're almost here. Test SIMH. Open with Kate. Set TTI 0 dasher. I think it's TTI 0. Attach DKP 0 RDOS, whatever the thing is called. Okay, attach DKP 1 new dash floppy dot img. Well, first we'll set DKP1 to 6030. That's SKP1, and then we will boot 0. Now, test SIMH. We'll go to SIMH, and then NovaScript. Boom. Okay. So, enter C111. Boom. Date 188 111. Okay. So if we do a list here, these are the files that are on there. And I now regret what I did. Hold on, reset. Okay, it crashed, so that works anyway. We're gonna rerun this. SIMH go. Okay. sysv is probably a copy of DOS in it. I don't know. There's also a sysgen, which is apparently different. So, okay, we're gonna do FD in it. Was that it? F in it, D in it, D in it, DK in it. That's it. Okay. Okay, so we're just going to do this really quick. 6030, disk unit, DP1. Okay, that's correct. We're going to do a full here. We don't want a co-resident diagnostic area, and I actually have to type all of no. We're going to do a 1. I don't really want to do a thing. We're going to do defaults for everything else. Full disk init complete. We can see that the floppy is the correct size now? What on earth? Dude, I feel like I'm going crazy, but whatever, fine. Okay. Now we can reset, okay, or we can just have it crash. That's cool too. Now I can go rerun it. File name, continue, C, 1188, 111. Okay, we can list. There's the files there. Then we can list. No, then we can, what is it? Dir dp1. File is not, is it just dir dp1? Dir dp1. What am I forgetting? I thought dir was how you changed. Dir dp 0. Yeah, okay. There's something else I'm missing. How do we format the disk? I forgot. Drat. Just init. Okay, init. F DP1. Okay. Confirm. Sure. Illegal file name. Okay. Maybe caps. Device already, you know, screw you, stupid. Dir DP1. Fine. Whatever. Gosh. Okay, so list DP0. Okay, how about we list DP0 with dir dp0. Okay, so if we switch back over, list. Okay, so we can see, let's go with something nice and simple here. Bootsys.sv. Pretty sure that's a program. We could also do dk init, but that's sd as well. So if we do xfer bootsys.sv to dp1, like illegal file, you know, you're real needy, Ardos. Xfer bootsys xfer, excuse me, bootsys.sv dp1 bootsys.sv there list dp1 dp1 list. We have the file there, but we are missing the metadata. So this is what happened. We did not transfer the metadata. Okay. So we need to figure out what the flags are for xfer. Well, there might be a way of just setting the attributes as well, but I don't know. Software, operating system, RDOS. learning to use your RDOS system. Okay. All right, you guys ready to read a manual? Yeah! Okay. Let's see here. What exact error was it giving me on the computer? No big deal, but I'm just gonna go look at my real micronova that's running over there. It's just kind of hilarious. Okay. Reading like this. Okay, how to do... So, I don't know where the exact source of the super high frequency chat are. No way. I wish this was OCR. Is there a command that's chat R? Anyway, hold on. I need to go put a thing in front of something, because there is a reflection coming off of that where the super high frequency whine from the floppy drive is just going straight into my ear and driving me insane. I wish for OCR mounts to OCD. So, okay, we want this one. Shatter. Oh, it worked. List. Okay, so chat R boot sys.s.sv. Not enough arguments. Intriguing. Chat R boot sys.sv SD. Illegal attribute D. Section of chat R also includes the bit values of each attribute to be very useful for decoding directory entries. Plus SD. Well, okay. Okay, I probably picked the wrong RDOS manual there. I love it. List. So we got S. Okay. Well, I think I'm done at this point, because I have a feeling I'm going to get an email in a little bit here. So I think we're on the right. D is defragmented file. C continuous. What? What? How? What? What's the difference between a defragmented file and a continuous one? If it was a fragmented file, that would be different from continuous. Well, 0. One, just do this. Before you put it to flux, just open the disk image up and then set the attributes. D equal fragmented. Okay, that makes more sense. Yeah, couldn't you just boot it in SimH and then set the bits? Docs seem complicated. That's because they are. Maybe we want this. Contiguous is continuous chunk of sectors on disk. D random. Sure, that's why that's a requirement for executables? Because it is. That is a very weird one. Oh, we got chatter. Boom. There we go. Attribute. Okay. Yep, protected. Executable. That. Sure. Okay. Move. Vo is not a command, just, you know, for records. copy files. That's so weird. Why are these two, why does xfer and move exist? Yeah, move is copy? What? And then you have to pass a flag for deleting the files from the source location after. I mean, that's weird. I do like that it specifies once transfer is complete. So if it like fails or something, theoretically it shouldn't delete them. I will say, I think this is the one I was reading earlier. If you look at the top of this one, it'll talk about some of the commands. Some of them are basically aliases for other commands, but it made it seem like transfer is kind of the one to go for. So I don't know. This is very confusing. Let's see. Overview of the CLI, blah, 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 blah. Okay. Nope. This is not the same manual I was looking at before.
Tier 2 and says, oh look, 0x21.months. End of line.
I am confused. HMS, thank you for the tier 2 sub and for 33 months. I really appreciate that. For some reason, it didn't show up in my activity feed. I'm gonna just refresh that page. How do you transfer while keeping the file contiguous? Just transfer the files to a new file system. Okay, I don't know how many RDOS manuals there are, but this is not the one I was reading last time. This is very frustrating. It's covering the exact same things, but completely differently from the other document I was reading. Oh my gosh. Yeah, Ben, that makes sense. Yeah, I get that. All right, well. Oh, man. Can make an SV from a binary. It's worth looking up. Create an executable from an absolute binary file. Yeah, so by the way, it calls essentially EXEs save files for some reason. Wait, do you have to... No, it's making the file A. Case... At location 0. Note the save file is not executable under RDOS. Save file as it's a save state of RAM. So this will save a core image file. Oh my gosh. This is sysgen on that thing. So on the HP Series 200, oh, anonymous gifter, thank you for 6 months total gifted to Diego. Wow, thank you so much. That thing, you can load in all the TSRs and the operating system into memory, and then you can run, I forget exactly what the command, I think it's sysgen, and then it'll save it all as one big blob on a floppy, and then you can just reload that next time. So I guess that's similar to what this is, but it does it with like raw binary code because it like doesn't do TSRs or whatever. Icarus, there are like 2 ongoing attempts to decode the images. There's only one encoder available that I'm aware of, and it is being worked on by Zero Ohms here. Huh, interesting. Wait a minute. What interfaces are the paper tape readers? How move's supposed to work from one drive to another? Why not use chatter on the image you already have made? That might be easier. I don't know how many files you had transferred, but that might be easier. Mag tape is just tape. 60/20 tape controller. Oh my gosh, I have to go shut off the floppy drive. It's killing me. Oh my gosh. I don't care if there's a paper tape reader listed for the Micronova. Technical manual, okay. Is this paper tape? Tape transport. What is this? That is not. What is a data general paper tape? Data general paper tape reader. Okay, how about must include data general? There isn't one. Because of these. Zero, you get this working. I can take it from here. So, what was it? This MK? Nope, this isn't even the one. This isn't the one. Where was it? I mean, other than the fact that I can't extract files, but okay. So here's my thoughts right now. Learning to use your RDOS command line interface. Okay, so the MK whatever thing it was, what was that one called? MK, no, MK, yeah, MK save, was that it? As our paper tape example? Just show me. Yeah, paper tape. So, doesn't matter what it is. This could read paper tape data into a file, which means that we could transfer files via paper tape. We can use this to get files into the RDOS file system via serial. I don't know that it's actually going to do any file type validation, Ben. I mean, I don't know that it will or won't. Whatever, 4011. Paper tape reader. Okay, how does this connect? Is there an interface card? So I think Usagi's 1210 came with just some random serial one, right? Oh, I don't like this. High-speed paper tape reader, adds 1-inch wide, 8-channel, fan-fold Mylar, paper tape, speeds 400 frames per second reader. Maybe this won't work. I thought that you could do... It may not even be necessary to pretend that it's paper tape. It might be possible to do it from TTI. Because TTI is a serial interface, so that might be just as acceptable. We don't know enough about RDOS to be sure. Make an absolute binary file from a core image save file. Okay. Converting files that are executable under the operating system to an absolute binary file that can be executed on another machine without RDOS. This here may make it possible for me to take something like sys.sv, convert it into an absolute binary file, and then just stuff it in RAM over there. Now the problem is we would end up with an absolute binary file. We need to output it to something. I don't know how SimH is going to handle this. So let's experiment and explore a little bit here. So I'm just going to run SimH in this directory. Actually, we're gonna cd into SimH because it's a little weird. So let's do show fi. So we have paper tape punch. We also have LPT. I'm kind of a fan of paper tape punch. So could we attach new tape.bin to PTP0? Non-existent. Okay. PTP0 tape.bin. Create a new file. That works. One moment. I want to grab something so I can be the super lazy here. I want computers, hardware, systems. Why is this not alphabetized? Systems. Other data general. I like how you can see what I'm doing because I have my history up over here. So, MU SimH. This. Yoink. These commands are just wonderful in SimH. You can program SimH to have a response to a command that it can automatically do. So when we boot up SimH, it'll be like, oh no, the hard drive wasn't closed. Hey, what's the date? What's the time? I'm so sad. So what we can do is we can just tell it shut up and it'll automatically answer all of the stupid questions it has. So now we can just do SimH, boom, and hands off automatically logs in for me eventually. There we go. So we might have the paper tape reader now. What I'm gonna go ahead and do here is close this. And then I'm gonna comment that out because I can just run that and that'll let us check that it is good there before we start the emulation. So now if I do show PTP0 attached paper tape bin 8-bit, that should be good. Okay, boot DKP0. So let's try this. I mean, MK, it's exclamation point, MK, ABS, foo, PTP, block, 1000 starting address. I mean, sure, we'll do 1000 just for giggles because we don't know. I don't have a paper tape reader. I don't need a paper tape reader. What I need, I'm just going to stuff this into RAM at address 1000 using my software eventually, maybe. MKABS sys.sv PTP 1000/A. Illegal file name. MKABS? Not enough arguments. Okay, MKABS sys.sv to not that PTP 1000/A. Boom, too many arguments. Okay. Why? You're making me sad now. Oh my gosh. Let's try just make crabs sv dot sys dot s dot sv ptp. What we got over here now? just now. It's 32K. Open with imhex. I don't know why I didn't do the address thing, but like, sure, I don't really care. Reload, whatever. I don't whatever. I don't care. Tape.bin. Okay. Interesting. This is byte swapped. It's very byte swapped. I don't know if that would be a problem for us or not. Why couldn't I set the address? Do I need to do it first or something? Is the manual wrong? Starting address F. So start block. Starting address, absolute binary start block. We output with starting address specified. Yeah, Stoney, you're right.
Tier 1 gifts up to 5 viewers.
End of line.
Emulate ATG, thank you for the 5 gifted subs. I really appreciate that. Yeah, we'll just try something. I wonder what happens. I'm gonna close this, and I'm gonna kill the file because I don't want it to just keep post pending to it. So let's rerun this. Actually, let me uncomment the boot thing because we understand how this works now. What have you missed for the last 20 minutes? We might have a way of running a program file by just shoving it in RAM. We're trying to figure it out still. Starting address, absolute something or another. Okay, so make ABS sys.sv to PTP / S1000. Illegal numeric argument. Oh, they prefix the value? That's super weird. Okay. MK ABS BS sys dot SV PTP 1000 S. Erlergal file name. I'm going to assume that I screwed something up there. MKABS sys.sv 1000 / S. That worked. Okay, is it 32K again? It is. Okay. I think that's important. I don't know what value it should be. I don't remember any values above 1000. So I think we're good. Because, yeah, it's the console debug ROM there. And then we got the weird, like, jump loop right there. So 1000 might be, like, a good, solid address to use. Okay. Now we have to reverse our code. In this thing. Here's the other thing. Okay, I haven't said this out loud yet. We get some kind of bootloader going that asks to run a save file, okay? We don't know what all that bootloader does. It is entirely possible that sys is reliant on something in the background and that we can't just cram it into RAM and be all happy. That's very possible. It's also possible that this random RDOS version of sys that isn't made for a micronova won't work. So, yeah. If that's the case, another option we have is using the disk image. Well, we'd have to decode. Actually, hold on. How big is this file? Wait, there is no sys.sv in here. That's right. I think we're, no, are any of these files 32K? So, mdos, mboot sys. Well, no, there is no sys file in this. That's why we're not going to try and do that. I know RDOS tries to load sys. So like if we do, we close this, go back to our SimH setup, and then we kill all of that, and then we rerun this. So it'll just start out asking what we want to do. So let's run this in SimH. Did I not save the file? I thought I did save the file. Why did it? I saved demo, not test. SimH, run. sysv created by sysgen. That sounds like a question. Okay, so here if we just run sys.sv, we get the exact same response. So that's why I want to put sys. You got me wondering though, Janko, curse you and your questions, sysgen. It looks like, no, it's a completely useless program that isn't going to do anything similar to what we want. No, I don't want to run Discover. Was there a sysgen in here? Oh, hello. Well, it's time to find out what files are in this image. GW, convert, boot test, the thing 00.0 raw, to format data general.fm.ss to thing.img. Hey, okay. I'm gonna grab this. I'm gonna stick it over here. We're gonna go back to this, and then rather than new floppy, it's gonna be thing floppy. Okay, this is not gonna work though. I need a program that someone wrote. Hold on. Come on, swap. Boop. Code, clone, go back to here. I need home, git clone. Bin swap, let's just go ahead and move thing over here. Then we will do bin swap thing. And there we go. Just rename this back to thing.img. And there we go. So now, double check this. Yep, that looks like a text file. Go back to here. We'll run. We'll close settings that opened for some reason. We'll run SimH. go. Now, dir dkp1 dir dkp1 Why? That's a good point, Majenko. I should do the correct syntax. List. A. Okay. Sysgen. Not a chatter. Chatter. Sysgen. What was it? R plus S. Chatter. Sysgen plus S. Yeah, I didn't think it was chmod. Wait, hold on. Chatter sysgen.sv plus S. Oh, okay. Sysgen. Sysgen.sv plus SD. Illegal attribute. Oh my gosh, that's literally how it's supposed to work. That is potentially way more useful. Although, I can read the file, but also the file isn't there. Oh my god, I know D can't be set. Just... So I'm curious, did it append to this? I think it did. Okay. I'm gonna do this. I'm gonna close it. I'm gonna delete tape bin. Indeed sucked, but new disk incoming. Okay. We'll give that a shot. Sysgen is just on there, and then we're just gonna abort all of what I'm doing here. Because this is a nightmare. So it did stay. Center. mkabs sysgen.sv to ptp starting address 1000. Okay. So this is sysgen.sv/tape.bin. Out of curiosity, if I just delete that, mkbs sys dot, there is no sys dot, you know, I just run this again, gen.sv ptp 1000/s. Does it just make a new tape file? It does not. I've got mail, all right. Okay, we got new raw files to test here. Bootier test. Sure. SV save from printer to read it back. Ooh. Wait, SV save, is that a command? SV save? Or you mean the MK save? MK save. You might be onto something there. It's a very, very frustrating workaround, but I kind of like it. It was tape.bin. Hold on. We will definitely try your file there, Zero, but I think this would be hilarious if this worked. And frustrating. I gotta know. Okay, so MK save. Hold on, let me look up the syntax. Because I need to know what the... Can I believe it? Okay, so file, pack1, we'll just pretend that that's not a thing. I don't know what Z is. Create, save file, beginning location. Save file is not executable under RDOS. I don't even know what that means, but we'll just, we'll try it twice. Why not? Okay. So MK save, let's try nosy first from PT. Wait a minute. How goes it? Really complicatedly. Is paper tape reader and paper tape punch different? They probably are, aren't they? Show fee. Yeah. Okay, hold on. We gotta kill this. PTR. Okay. MK save. PTR. DP0/unova dot. You know what? It looks like it's going to do the extension automatically. Okay. Unova. Not unnova. Unova. Okay. So we have a workaround. Just for giggles, we're going to run through this. Okay, it's a system for a micronova. Oh my gosh. Ah! Okay, yes. Processor type. It is 0. Okay. Number of 38 enclosures would be 0. 3095 or 60, that would be 1. I assume it's primary. Number of whatever them doohickeys. 0. 0. Enter bad block. 0. So I guess 38 is also for the 39. But oh well. Enter number of stacks. 1. Number of extra buffers. It's got a default. Maximum number of subdirectories accessible at one time. There's no mag tape. Auto restart on power fail. Absolutely not. RTC, I got no clue. Paper tape reader, I wish. Paper tape punch, I wish. Enter number of LPT, doesn't exist. Card reader, doesn't exist. Plotter, dude, a data general plotter. Implicit Micronova 6095 compatibility. Well, it's the only machine that the 6095 works with, so it should be. Quantity 0. Ohm? No. ALM? Wait, I think that's the async, isn't it? I don't know. Column size for TT, yeah, 80. Second TTY, I mean, there is. Column size, sure, why not? Core dump? Nah. File does not exist. Ooh, okay. That's what I was wanting to see. So it does need some other files. Okay. Well, we got a disk to write. So, we're going to use this. So we're going, this is virtual Nova, green is fake Nova, gray is real Nova. We're about to use the real Nova, but first I got our disk to write. So let me go grab that. Yoink. What? Pop that in there. Okay. So we're going to go to here and then get right up 00 and go. Okay. And then we'll see what happens. We know sysgen is on there, so we can try that. Actually, while we have this here, hold on, dp1 dir dp1 list. So this is all of the files that we should have on this disk, I believe. sys5 lb mboot edit micro dboot. Okay. CLI.er syslb. Okay. Managed to compile anything on it? Oh, we did. Compiling requires a language. We don't have that. Dump and load work for Pt8 2. Dump writes to the tape and overwrites your files. Suddenly load dumps everything on the tape back with their quirks. Okay. Let's see. Is that not the boot disk? It's complicated. Cannot rest until he's using Micronova to drive a plotter. It's not impossible. It's just awful. That far into the six. Let me put it this way. The actual objective for today was to use a Python script here to just directly read and write RAM. That's the level of pain we're in for right now. All right, so watch that space for data generally stuff. Turning on 8-inch drives so that I can cry more about the high-pitched whine. Turning on the computer, it's in reset, and run. Okay, there we are in console. So if you haven't seen this, Cody, which you probably haven't because the second video is not out and released yet. Here we're reading the address. You know what's funny about the earplugs? I actually have them right here. I could. It's one of those weird times where the strange suggestion's actually valid. That is actually better. So we have, I'm reading address 1 right here, and we're getting a value back, and then I can just continue on through different address registers for RAM. And we can jump around to somewhere different. So the actual code that's running the memory address reader here, we can read around this area, and we can see the code that's running just this. So yeah, but first here, what we really need to do is we'll try booting that disk. It's probably not gonna work. Is there a monitor of any kind, or can we just peek poke? It has some rudimentary debug stuff, but it's not super advanced. You can set a breakpoint, A1 breakpoint. Yeah, so that didn't work. Let's boot the actual boot disk. So I'm gonna go back to reset. I'm gonna swap over to the one that has the good boot sector. Go back to run. I'm gonna execute 33L, get us to the file name prompt. There it is. All right, now I'm gonna put in the other disk, and we're gonna explore what we can run.
Very sorry, demasiado código. Simplemente vimos buscar X. De lo contrario, los datos valorant soy my melo en los datos CHER 100. End of line.
Jason, thank you for the 100 bits. Okay. So I don't think we can run sysgen since we don't have whatever files it wanted. But for giggles, let's just run it so we can say we've run it on the real machine. That was wrong. Hold on. Probably want sys.lb. That is on the disk, but that did not run. I should have run CLI. Dang it, why didn't I run CLI? I don't know what CLI is, but it's probably better than whatever this is. Okay, so that didn't work. Let me reset. This is complicated because we gotta hokey pokey our way from the other disk. So what you're missing is me over here shuffling floppies around. See, this is where it'd be nice to be able to just like pop over here, 33L, pop back, swap disk, and then walk over to the computer, but that's not what we have going on right now. Why did it show address 0? That's kind of strange. I found out all these files need their byte swap. Yeah, not only does the disk image need byte swap, but the files do. Okay. So now we're at the point where we can potentially run CLI. Okay.
HIIMCODY 1 SIZCHEER 25. John Madden joke here. CHEER 25.eu.eu.CHEER 25. I promise I can be original, but not today. CHEER 25. Probably not tomorrow either. Anyway, have this dollar dot. End of line.
Cody, thank you for the 100 bits. There is no sys, because we have to run sysgen to make sys. Let me demonstrate something. So this is thing swap, all right? I'm gonna kill this. I'm gonna bring this in. This is the non-swapped disk image. I think I know why it hangs. Just one moment. dir dp1 disk format error. Oh. Okay, I think I know what it is. Yeah, this is.
End of line.
You need to swap the bytes before you write it back to Flux, I think. I think that's maybe is what's going on. I'm not sure. And Emulate, thank you for the 100 bits. I for the single breakpoint. But that's my best guess. I don't know. Ooh, I wish I knew how to actually get it to drop back down to the console debug when it hangs. Oh, you know what? For giggles, let's check something. I'm going to reset and then to run. Two. Ah! Data. There's more data. Okay. That's good to know. So reset does not clear memory. I was unsure about that. So 2R? No, that didn't work. And now I gotta go reset it again. That one's my fault. Data's now invalid in RAM, but whatever. So we got to 462. 462. Close enough. Yeah, that's clearly code. Okay, so it did load into memory. Was boot selected from the original boot disk on the image? Okay. Yeah, that might help too. I don't know. You know. Hold on. Let me. Well, I mean, this is an interesting concept that we can do now. I'm gonna fully power it off. Pulling the new disk. I'm putting in my boot sector disk. Reset, run 33L. Okay. Reset. I'm removing the disk. Back to run. We can go 0. And then we can see all of the data that's being held, that is from the boot sector, which means we can also go do this. So we're gonna go from 0. I don't know how far we want to go. 1,000 read. Holy moly, it's big. 2,000 read. There's still 3,000 read. That's still 4,000 read. Hold on, K. 4,000 read. 5,000 read. Okay, so up to 5,000, maybe? As J. Yeah, okay, up to 5,000. 0 to 5,000. RAM boot. I don't really want the JSON. All right. Oh, why? Oh, because I still have this connected. All right. Have fun! Do we need this? Not really. Do I think that it's kind of cool? We can? I mean, yeah. I wish we knew where to start it. Yeah, the serial port is slow. I can't get it to run any faster. I tried. I mean, I could possibly change the jumpers, actually, increase baud rate, but the timeout, I think, is what's killing us. Majenko, I've tried that before. Control A doesn't work. The system actually locks up. I am resending the read address every time. Yes, you are correct that I could be just reading or pressing carriage return, no, line feed, and then getting the next value. So this is slower than it needs to be, but come on, how often are we realistically going to do this? We don't need to, like, hyper-optimize it. And to that end, Majenko, I think it was you who were asking why was I checking for the last address, because that is how I was initially going to do it, but then I changed my mind. We're almost halfway done with just this command, so it's not going to be that bad. We will use the more efficient method when we write data, because we're probably more likely to do that repeatedly. The wrong bird, that was you? Okay. It's kind of awesome to be able to do this. Third image in the mail? All right. Got it. I guess we could try writing this while we read the RAM. kind of really fun to be able to just dump RAM like this. That does nothing and need back to planning. That's all right. I fully understand. All right, boot est. I wonder where it's going to stop, because it's possible that 5,000 wasn't enough. Well, that looks like repeating patterns, so there we go. Around 4,700. And then it just ended? That's weird. Oh, wait, no, that's correct. Okay. Yeah, it reached 5,000, I know. Okay. Cool. For giggles now, we need to open that because we should see file name in there somewhere. That should open with imhex. Which is still open. Okay. So it'd also be fun to compare this to the floppy image. Okay, here we go. Oh my gosh, seeing, it needs to be byte swapped. Stupid data general with your weird. Let's go ahead and byte swap our RAM. There we go. It's not endianness. It's literally the two 8-bit sections that make up a 16-bit value need to be moved. All right. Insufficient memory, overlay, file must be contiguous. File not executable, link depth exceeded. Ooh, there's some good stuff. That's what endianness is? Oh, well, I thought it was like the order of the bits, not the bytes. Never mind. Device not a top loader. It knows what the best kinds of VCRs are. Hardware failure. I don't like that one. Invalid disk ID, then a bunch of stuff. Partition in use. Type C to continue. Oh, that's really interesting. That's in that? I wouldn't have guessed that. Oh my gosh, this is so close to being useful. Ugh. Okay, that was genuinely useful to look at. Okay, I am putting these in here. That will automatically upload them to my server there. Okay, where we get this from? I just dumped RAM from the computer live. So that's the RAM from the one boot disk the original one I had. So 0ohms, I don't think that's boot SV. I'm pretty sure that's the raw boot sector at the start of the disk before the file system part, because boot SV has to be in the file system, doesn't it? Okay, the floppy is in, the machine is reset. Okay, that's not actually interfacing. Here's this. Okay, 33L. I expect this to fail, no offense. So we'll see. Copyright and... Oh, it worked. Oh yeah, because you stuck the loader. Beautiful, okay. Sysgen? Copyrighted versions on boot SV. Huh. Yeah, this is super frustrating. I wonder if it just has to be. Oh, wait, hold on. No, we're not done. Wait, we got one more thing. Did you put DOS in it on there? Yeah, so what Vorpal Sword is saying is what I was about to say. I know for a fact, well, hold on. Okay, well, I just screwed that up. Oh, that'll work. DOS init, I think, is the Micronova equivalent of DK init. Oh, no, it didn't crash in a different way. Ah! We just ran a program off of it. There you go. That actually worked. Okay, we could go kind of format a blank disk. Okay. Zero, if I could pester you, I know what we need. All right? If you're willing to make 2 more disk images, we can do this. So let me figure out exactly what it is we need. Okay, all right. So DP1. Hold on, it's the wrong file in there, I think. We need to get rid of thing. We need thing swap. Okay. Yada yada. Okay, DP1. dir DP1. Sysgen. Hold on. dir DP0 sysgen. Okay. So no, it was Unova. Wait a minute. Control A. Ah! Simulation stop. You know, that works too. Unova, that's what I need to run. It's already on the hard drive image, so I just need to run that. When we ran sysgen, it needed 4 files to be able to work. So I need those 4 files in a disk image, and then I'm going to make a sysgen file that will be in the hard disk image, but I might be able to copy it to a floppy, and then I can send that to you, and then you can make flux from that. So that's what I'm thinking. So Unova, file already, yeah, I know, I want to run it. I guess I have to run it. Unova. Why? Okay. Let's... this. Tailored setup disk, yes. But we need the files. I just don't remember what the files are. Okay, Unova. Partition in use, whatever, continue, and... I know we ran this before. Well, that's weird. Why does it keep saying file already exists? You know, fine, screw it. MK save PTR DP0 UN there UN file already. Do I need to give it an output file? UN, I don't know, test. Dude, RDOS sucks so much. Why does Unova not run? What am I missing? Sysgen. Okay, so we do need to do an output. Unova test. Dude, how did we do this? Well, I tried, Ben, not to... So I've done this. Unova. But then it hangs. Need to be away 1520? Okay. Well, this probably isn't going to get done on stream, so that's fine. So that doesn't work. UN? The new one doesn't work either. I'm going to take off the earplugs because I think I'm talking way too loud and I'm kind of hurting my voice more than normal. Dude, I don't remember what I did. I might have to go back and watch my own stream later, which is going to suck because I don't remember when I did it. Because it had an output where it said, we need these files, and it was blah, 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 blah. Volume level is normal sound. Well, the volume level is normal sounding, but that's just because it's limited. Yeah, so Pordizo, we're kind of past that part. When you read the paper tape back to the file, yeah, I know, but...
77 has Prime for 5 months and says, end of line.
Emulate ATG, thank you for the 5 gifted subs again. I really appreciate that. Unless that was... Wait a minute, hold on. Twitch is being weird. No, Lucky Pub, thank you for the 4 months of sub. Dude, I don't know what it is, but Twitch keeps not updating the background, the stuff in the background. Never mind. Disregard. But Lucky Bob, thank you. Okay, so I've already read back the paper tape. That is the file Unova and UN here. Those are the same file. They should be able to be run. I don't know why they're not. But wait, I got an idea. Take this. And we're going to go to home and git and bin swap and put it in there. And then we're going to run bin swap sys gen tape bin. And now we got ultra super long file name in hex. All right. Then we're going to scroll through this. Okay, so this is the sysgen file with the proper arrangement. So it needed files here. We're just gonna find the files. Here. Yada yada yada. It asks a bunch of things. Okay, yada yada yada. MS DOS A. Yeah, that's what I thought. Okay, let's look for that. Hold on, let's just double check. M DOS string. M DOS. Okay. There we go. So, effectively, we need all of these, whatever exists. Copy as ASCII string. New file. I hate that startup page. Why? 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 No. No, 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 no. What is this nonsense? Copy as escaped string? That sounds awful. No. Copy. There's like zeros in there, so it's terminating it. I got a stupid idea. Okay. And now we just get rid of anything that looks stupid. Eh. 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 Wait, 6432? I have no idea what that is. Okay. Boom. And boom. All right, there we go. Yeah, I may have missed a character. There we go. Okay, boom. Grabbing all that. Okay, I'm emailing them. Okay, actually, hold on. We can check this. Because we have the floppy file, or the tape files. Here we go. This. Okay. What all are here? So, type. Yeah. Okay, so it might be MDOS A, probably. Yeah, MDOS A. I don't think there's going to be a ZM DOS A. That's kind of weird. Okay. Okay. Wait, MDOS I? Yeah, that is there. Okay. You have before MDOS, no Z, whatever, it's fine. I'm not, this isn't software. Okay, do we still have imhex open? What do we have? We have the swapped bin. What is the end? Does anyone have any paper tape punch experience? How does it know when the file is done being read? Or is SimH probably sending it some kind of magic character after the end of the binary file has been reached? Because I don't think it's just a bunch of zeros. Yeah, but how does the computer know to stop looking for more data? Because the whole, like, purpose of paper tape is that the speed is not, like, locked since it's parallel. So the paper tape could be going slow. There is no guaranteed data rate. Isn't end of file zeros? But maybe it's that. I don't know. Anyway, there does not appear to be a DOS-I file. It's gonna make me look at DG manuals again. You do not have to, no. Slice theatrically puts the sandwich down. Don't do it. Don't do it, Ben. The only reason I ask, though, is because it will be important for when I try to send files over TTY to the Micronova. This paper tape thing, by the way, if we can crack this over serial, it should be easy to get data onto the Nova 4X. I've been concerned about how that was going to work since I found out that the 6039 is not compatible with anything in the Nova 4X, and that I only have 2 platters that I can swap between them in the 6045s. Wouldn't be great to exercise those that much, so... If we can emulate... Yeah, 4X is going to be complicated. I really don't want to have to boot the machines from hard drives. Like, that is a big goal of mine. I don't want to have them spin up the drive to use them. I want to be able to, because it's fun. But I don't want that to be a requirement, because there's going to be a sad day when hard drives die. It's not an if, it's a when. And I would like to make sure that when that happens, it's not game over for the computers. So it's part of the reason why I'm putting so much effort here into this stuff and why I'm so fixated on loading software over serial, because that is the only way the 4X is going to work. It's one reason why I'm network booting for my VAX. Yeah, when you find an Ethernet card for the data generals, let me know and I'll set up PXE for that thing. Boom, right there. Programs usually recognizes the end of information field on the tape. Some predetermined contents, frames of bytes will signify end of tape. Second method determining tape. So knowledge of the total number of frame bytes on the tape. Oh, well, okay, then that makes it super easy. You scoff, but it's perfectly possible. Yes, it's also possible to make a SCSI card for it to boot off of a CD drive too. Just as likely to happen though. No, the floppies are not RS-232. They're a custom, like, weird... Isn't the signaling even differential? Just like, it's the back plane of the cards. It's not a protocol. Can I use the chat to control it? No. Hard drive emulator and a Pi Pico. I don't want it to come to that, but it may at some point. And if it does, that will do it to the 6045 drive itself, because then the work will be reusable between both machines. Well, the best long term is that I just develop an SSD that goes in them that has, you know, solid state storage built in, doesn't even require a Pi. Best is not the metric that we're trying to hit. Practical is. Serial that requires no new hardware to just load an operating system straight into RAM is extremely practical. The best realistic? It's not true. Check this out. Let's see. Technical reference. PROM. Programmable read-only memory boards, aka SSDs for the Micronova. Contains data on it that can be used as the boot section for the machine. They exist. They're out there. I could recreate that if I really wanted to. That wouldn't even be that unreasonable. There might be schematics or something. The biggest problem is the custom chips and stuff, and what code goes on there. Note it doesn't say EEPROM. Well, I mean, yeah, I'm not pretending that it's going to be a disk drive, but if I made one of these, stuffed just enough RDOS in it to get it kickstarted, that's not bad. So yeah, it was totally a thing to boot these computers off of solid state. All right, where are we at? What can we actually accomplish right now? So let's think about this. I have no idea how they work. I haven't looked into it because I am not seriously considering it. All right, so we have not attempted an address write function here. It's basically you do an address read, then you type in a value and then hit next, essentially. Is N correct? I don't actually know that. Let's see. Let's find out. I'm going to reset the machine and turn off the horrible floppy drive. All right, I'm fully resetting the state of the machine all the way to power off so the RAM is cleared. Okay. Let's make sure we're not connected in Minicom, which I do see it's open still. Not because I don't want to warm up T-Soldering gun tonight. Yeah. I'll say this. I'm getting a little brain fried. 4 hours of this, or 3 hours of this, is starting to wear on me. We have done a lot of technical stuff. Okay. So we want an address right. So we'll do address data. All right. We will do an address read. Because the way the syntax works, you do a read to open the cell, and then you can just type in whatever you want, hit new line or carriage return or whatever, and that's how you swap out the contents of the data. So we're going to need to do data to octal, replace all the blah-de-blah-de-blah, and we'll pop that back into data. We'll do this, and then we'll do command next. And we'll read only to clear the buffer, but after that, we're done. Because it goes to the next thing there. Needs to change keyboard. Yeah, no, pass. I'll make this address right. All right. And then we will just grab all of this and crunch. Okay. DG address right. We're going to set, let's go 2 to 042. All right. And DG con. That might have worked. Let's find out. Enter, 2, read, bam. Yeah. Okay, well, that was fun. 45-minute little excursion there. That was so hard. Oh, gosh. All right, now what I want to try next is, let's do data, num equal data. Sonam's really great inventions and something else. Zero, did you get my email? So I looked through the file that I wrote out to the paper tape reader here with imhex. And at the very end of the file, it has all of the files that it was trying to access for sysgen. So I think these are what we need in there. And I think they're basically just the these files, really. I'm not sure that there was anything else in there. So it's just the MDOS stuff needs to be added. Anyway, back to this. Here's what I'm gonna do. Data, num, okay, address. Yeah, all that fun stuff. Okay, we'll read, yeah, but then we're gonna do this. Data num plus equals 1, and then we're gonna do this. Okay, I wanna see if we can set 2 and 3. Right, 42. Okay, let's go back to Minicom. 2, okay, and then 3. Okay, perfect. So yeah, we just do next. Oh, this is gonna work. We're gonna have to figure out how to read the binary whatever nonsense. I'm going to need the tool to figure that out. So here's what I'm going to do. I'm going to create address right range start data. I don't know how I want to handle it, because I probably don't want to load the whole thing into RAM. Ben and Zero, have you guys heard Cake's cover of Phenomena? It's excellent. We're gonna call this right file, and then it's gonna be file name, because I don't think it makes any sense to do this any other way. Matter of fact, we're gonna do read range to file. And then grab all of that, stick it there. Or DOS-I, MDOS, or for different systems. Yeah, I don't know. It is weird. And DOS-O-LB, because if that follows the syntax that the manual describes for, like, parameters, these would be considered optional. So, to be clear, Zero, what I need back is the binary image file that I can use in SimH, because I need to run sysgen in SimH to build the sys file. Then I'm going to send you the sys file back to write to flux data so that I can write it to a disk. That's the goal. And if you can stick the bootloader like you did at the front of it, it may just boot straight up if there's sys file on there. So yeah, that's why it's like it's 2 steps round trip. I need everything to build the sysgen, and then I need you to write the sys file to flux. So yeah. All right, back to this. Read range. Okay. Oh, I need end equals end. All right, now for giggles, just to verify that this works. DG address, read range file, start at, let's go with 77400 to end equals, oh no, file name, right? Yeah, file name. Test.bin end equals 077500. Save. That's not right. Oh, 'cause I suck. There we go. And boom. Responses not defined on line 95. Yeah, we don't need that. Okay, boom. Okay. So now we got a function for reading file range, get status. I swear I could type. Git commit better integration of file reading and can write single RAM address. Git push. You also have, it should be
NATI 63S as tier 1 for 10 months and says,
End of
Oh,
line.
yeah, good catch there. Why did that work? Wait a minute. How did that work? Okay, I gotta apparently refresh Twitch because it's sucking over here before I could actually know what that was because I was talking. Natty63 of a tier 1 sub. I really appreciate that. Thank you so much. Yeah, why did that work? Let's just, well, I accidentally did a commit already, so sure. Did I like... No, I didn't declare DG before. That's strange. Okay, we'll just do a git push since I already did a commit and I don't really care. Okay. Man, this sucks. This is awful. Okay, let's keep going. So we want to write a file, read range file, write file. Okay, so let's move this. Yeah, I feel like I just hit middle click and like screwed some up. I did, that's why it feels like that. Okay, write file. Okay, so we're gonna do, it's not like there's a lot of logic to this. Get rid of that. I don't program, just push it, I don't care. That's just the same commit name as before. It's not like it really matters. Okay, so we need the Hydro Thunder time tool because that'll tell me what the commands are like for reading things. So there's construction going on the roof and it is extremely distracting. I'm not even kidding. It sounds like they're playing bowling up there. It's all right, open with RB. We can seek to, we're not gonna seek, we're just writing the whole file. I'm not adding seeking. That sounds ridiculous. Microphone doesn't pick it up. I'm not saying you need to hear it. I'm just saying if I like act like a dog seeing a ghost or something, that's why. Okay, where's my write range? Write file, that's it, okay. Installing fiber, I wish. It's not hail on the roof. I would know if it was gonna rain. It's not gonna rain. Did I just get an email? I did not. Okay, write file, with open file, not self.filename, just file name. Okay, you know what, we'll grab all of that, put it here, and yoink. Okay. We're gonna go ahead and do a read address because we need to set the start point. Okay. So fread, we read. For a second there, I thought I like really screwed up, and I was typing read byte and wrote out read boat instead there. And I was like, how did I mess up byte for boat? But no, it's one byte that represents the boat in Hydro Thunder. that was extremely confusing. So we need 2 bytes as octal. This is gonna be fun. I'm not quite sure how this is gonna work. It might tell me to get lost, so we'll see what happens. Is that it? It's not that easy, is it? I feel like that might be it. Here's what we're gonna do. We're gonna write this to... You know what, let's just do it to 2. Test bin, we don't need any of that. Okay, so we're not gonna run that yet. The first thing we're gonna do is we're gonna go back to the console. We're gonna check that 2 is empty, because it should be. 2, oh that's right, 2 is that, that's fine. And then confuse it to no end. Okay, so all of that is like that, that's good. So we're gonna write up to 100. So we're gonna do that. And then let's find out. I didn't mean to do that. Okay, now we gotta reconnect. Hold on. This one can't? Why? Okay, hold on. I need my manager console. Connect 2 to 6. Invalid command. What do you mean invalid command? There we go. All right. Back to the Nova. Right. Okay. Address is not defined. Okay, yep, maybe we need struct to unpack. That's a complicated line. Tuple object cannot be interpreted as an integer. I don't think I'm going to like this. Unpack requires a buffer of 2 bytes. So are you kidding me? Be interpreted as an integer. Int? Don't mind me, I'm just casting things 30 times. Int argument must be a string, a bytes like object, yeah, whatever. What if we get rid of oct? Does that fix it? Kind of. Why did it write only one thing? With open. Because I don't know what I'm doing. Okay, with open. I think I need a seek while. Oh man, this is gonna suck. Python file seek and where's PyDocs? Come on, give me PyDocs. IO core. I'm not really super... All of a sudden, 8-inch drives there were pretty loud. Mildly concerning. Let's see. Python file seek. Just give me the PyDocs. Input and output. Beautiful. Okay. Seek. Okay. Okay, how do I know when I'm at the end? Okay, RB. See, go to the third byte before the end, read. Seek blocks times offset. Read times. Read bytes, of times. Right. Now. Byte count. Hey! Why are there commas? Well, that's weird, but let's just hope for the best. Okay. So go back to Minicom. 2 is 42. That's not good. Nope, none of that's right. What did I just do to this thing then? Right, 240. Why is it a tuple? Always returns a tuple. You want stupid. That's struct unpacked that's doing that. So I want that. Nope, that still doesn't seem right. Maybe right slash. What am I printing? Right slash. Where's that being printed? This is awful. All right, there we go. Sort of, maybe. I don't think that worked. But we'll find out. Okay, it worked. We can write to RAM! Yeah! Okay, there we go. That's what we needed. So, we can stuff code in memory. I don't know what happened there. That's kind of spooky. I actually really don't like that. What's the deal with that? Why are those showing 3s? Let's go. I'm gonna reset the machine. I'm gonna jump to address 100, and I want to look at that. Okay, it's good. It's good. Whoo! That isn't in your source data, maybe dead bit and RAM? Yeah, that's what I was concerned about. No, it looks good on a reset, so I think it's fine. Maybe it's just the data. All right. You know what we could do? You know what's a thing here? we could try something here. What's the name of this thing here? Yeah, it's called that. And it goes to address. So it said wait a minute. Manual? What do you on? Control F is SVABS? Was that it? No. Make ABS. Specifies, okay, it is octal. Good. 1000 octal. So, in theory, this will load sysgen into RAM. That seems like a lot of zeros. Ah, there's some data. I'm not convinced it's gonna fit, so. That bin already had the 1K offset? Wait, does it pad it with 1000 to start? That's awful. Is that how it works? I thought that was like you had to load it here in any like internal jumps. It would have the addresses offset by that amount. It writes a jump address and 700. So I have to add a seek? Yeah, I did create it with make ABS. Just loaded at address 0, but okay, fine. We'll cancel this. I guess set this to 0. Go. But it doesn't have a jump at the start. Well, just leave this for a bit. This is gonna take a little while. This is about 50% longer than the data that we dumped from RAM before. Although this is optimized. Yeah, this code is faster, actually. This should be faster. It's a pretty exciting moments proof of concept. Expect this to not work. I can guarantee you this program is not gonna work. How about we, oh. No, I shouldn't have stopped that. All right, let's restart it. I thought I was sending it the swapped one. I'm an idiot. I'm just gonna walk away from it. Disk sent. Oh no. Not the best timing, but okay. This is the more important thing. This is byte swap for SimH. Not all the files existed. Okay, that's fine. Then not all the files existed. Oh wait, I don't actually have to write this, so that works. Okay. So Zero, I don't know if you were paying attention to what we are currently doing. We are currently, just for kicks, sending sysgen via serial directly into the RAM of the machine. Found a way to execute? Execute is easy. You just type in a number and then hit R and it will start execution at that location in RAM. So execute is cakewalk. Bootloading it? Yes, but like a lot. It's not just a bootloader, it's just loading the program into RAM. It's more like paper tape. The bootloader would be just the stuff to get the paper tape to read into RAM. But this is just like cramming it straight into RAM. Okay. Cooperate this time. Okay. dir dp1 list. So MDOS, okay, all that stuff. And then you have sysgen in here, I believe. Yes. So maybe sysgen. Beautiful. Okay, I'm going to configure this for exactly my machine as it should be, at least as close as I think I can get. So, okay. I have 32 kilowords of RAM. It is for a micronova. Processor type is, I'm pretty sure, MP100. Number of 38 is what? Number of drives is 2?
100. End of line.
Ben, thank you for the 100 bits. Soft error reporting. No. 6095 controllers. 1. We'll make it primary. There are 0 of those, 0 of those. Enter bad blocks, 0. Number of stacks, I don't know. So let's try 1. Number of extra buffers required, it's got a default. Subdirectories accessible at one time, no clue, let's just go with that. Mag tape, no. Power fail, no. RTC, don't know. Paper tape reader, I wish. Paper tape punch, I wish even more. Number of LPT, doesn't exist. Card reader, no. Plotter, no. Quantity, I don't even know what quantity is. Don't know what ULM is. I think is the serial card, but I don't know. You know what? I'll set it to no. Column size, yep. Second TTY, yes. Column size, 80. Core dump, no. File does not exist. RLDR, ugh. We were off by 1. Okay. Can you add RLDR and send it again? Wait, is RLDR even on the tape? Okay, there are RLDR files. We were so close. This file wasn't listed last time. Was it listed in imhex? Yeah, right there. Adding those? All right. I appreciate that. Thank you. You know, it'll be really funny is it space on the floppy after I do all this, and then it doesn't work. About 50% bigger than the ROM dump. The RAM dump was 5K. This is more. It's 3 times. Can't copy the file over to the image through the emulator itself? No. Well, actually, I never tried accessing files on the mag tape through the emulator. Maybe? But I can't make an actual disk image, no matter what. Poot, that requires removing the serial cards from the machine and changing jumper settings. I'm not doing it. I also don't know what the full max speed is. The terminal can go up to 19200. Don't know if the computer can. But yeah, I'm trying to get to the point where I just stuff it all back in the rack and then never take it out again. I'm getting close. Ah, it ripped. It's done. Okay, here we go. It wrote 10,000 address points? Good grief. Okay, so 555 and then read. Yep, there is data. 700 and we read. There is data there. Why is there data there? I thought there wouldn't be data there. Okay, if we go to 500 and read, there's data there. Did it not work the way we thought it worked? We're just going to pretend that that's fine, Ben, because I don't want to think about it that much more. We got 7 minutes. Come on. Hold on. Here we go. So the first maybe instruction is at 310? So do we go to 310 and then try and run it, or do we go to 350 and try and run it? 350 looks more promising. Yeah, screw it. 350 R. Hey. What do you know? It didn't work. All right. 0 slash, there is something there. So 0 R, 0 R. Dump I started uploading worked fine. So I don't know. Like, just to sanity check here, let's grab ROM bottom, which is 222 bytes, and we'll stuff that at, we can't do it at 0, but we can do it at 2. Because 0 has protected stuff around it. That's why I didn't really want to do that before. So we'll start this. Why? What?
David Phantom says hello, only 3 hours and 56 minutes late. What have I missed? CHER 100. End of line.
Don't worry, David. We just solved all of it. It's all perfect now. Yep. For sure. You sure program that writes RAM empty? Yeah. Okay, 2. Why am I not getting a read back for 2? Wait, the machine is seized. Okay, let's just go. Just gonna restart it completely. There we go. Now it'll be a happy camper. I think my write program is fine. I think the sysgen file is weird. Was it an odd number of bytes? Was that the problem? Well, that's not my fault. I mean, it is my fault because I read an odd number of bytes from memory, but we'll just ignore that part. So if we go back to here, 2 slash, okay, 1, 2, 3, 4, blah, 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 that all looks like that. Okay, so then we go here, and then we go 77400 slash, so it should be 2000, 4456, 24,000, 44561, 40554. So that all looks good. So this is my dump of the console ROM, and this is the actual loaded console ROM, and they do match correctly. So, program is fine. If a bit chunky. Problem is you're just dumping a raw executable in memory and expecting to work without, say, the operating system. No, I wasn't expecting it. I said that. It probably would be missing those calls when we first started. I said don't expect it to work. I'm just saying. It didn't put data where I thought it was. Or would. That was my only concern. So what I think we could do here now is, just as another one of them checks for sanity, let's do this. Let's set this to 200. Run it. And we'll make sure that that ends up in the correct place. All right, yeah, wrong number of bits, whatever. Okay, 200, go. All right, that's looking good. Yep, that's correct. So my addressing is good as well. All right, well, I am going to get, actually I can run it here so it's nice and legible. That wasn't what I wanted. Where's my console manager? There it is. Okay, the C2 to 6. Okay. Control X. Control. Yes, leave mini comma. Okay. Git commit dash am write file available. Git push. All right, there we go. So Ben, in Dernal modem, that is how the serial switcher shipped to me. I didn't do that. And it was new. Actually, there are printouts in the manual of what it should look like. I wonder if the printout is in the manual. Or the typo. That would be kind of amazing. No, it's spelled correctly in the manual. But yeah, that's how it was. I didn't do that. I wonder if they have some intern there typing it in for them all. So, disco on the way? Oh, man, okay. All right. All right, we'll go a little overtime on this because it would be super cool to have this work. All right, do I have a SimH open? I think I have two. We don't want that many SimHs open. Man, it is wow, I got so many SimHs open. Jeez. On my laptop, SimH really makes it break a sweat. So it's kind of nice to have the Threadripper here where it's just kicking back. All right, here we go. DP1. Nope, DP1. Dir DP1. Sysgen. Okay. List. No, I refuse. Ah. Hold on, wait. Sysgen DP0 USys. Yeah, I'm gonna have to delete something. Okay. So what do we want to delete? DOS in it? Probably don't need that. Okay, is the command just delete? Delete DOS in it. .sv. Okay. Sysgen. Okay, that worked. All right, here we go. All right, I'm going slow again. 32 kilowords. It is a micronova. It is an MP100, I think. I have one 6038 with 2 drives. I don't want soft error. I have one 6095. It is primary. I got none of those. I got none of those. I got no bad blocks as far as I know. I don't know how many stacks I want. I don't know what extra buffers are. I'm hoping 0 subdirectories is good. I don't have a mag tape. I don't want power fail. Don't know if I have RTC. I wish I had paper reader. Wish I had punch. Don't have LPT. Don't have a card reader. Don't even know what the card reader is. Wish I had a plotter. Don't know what quantity is. Don't know what ULM is. Don't know what ALM is. 80 looks good. There is a second TTY. 80 looks good. Core dump, no. Ah! It didn't just like generate a bajillion files that time, did it? Oh my gosh. Hold on, disk. What do we got? Used 0 left. Okay, I'm gonna re-download the file and I'm gonna delete some more. So let me close this. Yeah, overwrite it. Take 2. All right. Dir dp1 list. Okay. Delete cli.sv. Delete dos init.sv. I need hold on, just for giggles, disk. We have 60 left, 42 contiguous. Okay. I don't know what else we could get rid of. CLI.ol. That's pretty big. You're good. Good call. Delete CLI.ol. Disk. Contiguous 100. That could be good. Let's relist. Okay. Last big file. Okay, I'm going to give it a shot. All right. Sysgen is micro. Okay, I accidentally set the correct processor type. 138, 2 drives. Don't know what that is. Have a 95. It is primary. Okay, skip, skip, skip. 1, skip, 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 skip. Stop! Nope, that's I screwed that up. We'll just delete sys.sv if this actually works. Go. RDOS error. Space exhausted. Dude, how much space does it need? CLI.er isn't even that big, though. I couldn't get it to write to the hard drive, let alone a second floppy. Yeah, I should probably... all right, I'm going to wrap this up. I can experiment with this off stream. Yeah, we might be able to delete boot.sv, check mail. Oops. To make a slimmed down one. What is this? Oh, okay. That's keys to the city. Okay, I can work on this as needed now. Thank you so much, Zero. That is incredible. Am I okay sharing that? No problem. Okay. We now have the ability to convert disk images to CryoFlux RAW. So this is an encoder for 2F, Data General. All right. I'll continue this off stream. I won't be able to try it immediately, and I'm gonna be editing most of this week, so I don't know when I'll get a chance to come back to this next week. Yeah, absolutely incredible, unbelievably awesome work, Zero. That is awesome. But I will figure this out, and then we'll see what we can do. Yeah, I definitely can do that. They don't make it easy. Yeah, boom. It's most likely tuned for the Nova format. Oh, absolutely. Yeah, no, FM does not... Normal FM is not Nova compatible. So, okay. That's awesome. Yeah, like I said, I'm going to have to go. We are going to have to wrap this up. All right. Well, today was an insanely productive day all around. Not only did Zero Ohms there successfully create an encoder for the data general floppy disks, but we also have a program now that can manage reading and writing from memory. So we can control the memory contents of the Micronova over the serial port from a modern computer using binary files now. Okay, that is going to be huge. So we have that power. That can potentially be rolled into emulating a paper tape punch or something to load files once we get RDOS going. It should be, Ben, as long as it doesn't crash. I've had so many RDOS programs that should work that way, but it, like, they just, like, hard lock the system. So, all right. Oh, we're on the precipice. We're on the precipice. But yeah, all right, we're gonna have to wrap it up there. We are so close. So close. I'm very excited. It's huge progress today. But all right, I'm gonna run the outro now. All right, thank you all so much for being here. This has been just an absolutely fantastic project. We are so close to making this thing actually do stuff. And oh, when we do, it's going to be awesome. So I'm really looking forward to that. We are, like I keep saying, so close. It's just, there's going to be a little bit of trial and error to figure out the next steps. So yeah, but I think we have all the pieces. I think we do. So all right, if you enjoyed this stream, you may want to follow to be notified when I go live again. Oh yeah, I keep forgetting to mention this. We have a data general emote now. I forgot to mention it all weekend. It's there. TT, tech, whatever, DG. Yeah, it exists. You can use it. I can't believe no one found it. You guys just all like you